Our test 3 material starts with chapter 9, and the first section we're going to cover is trigonometric identity. So we are going to first remind ourselves the basic trigonometric identities. They start with the reciprocal identity, and I'm going to write down the 6 of them. In fact, if you want to, you can actually make 12 out of these 6. So first and foremost, remember sine x is equal to 1 over cosecant of x. So similarly, one can say cosecant of x is equal to 1 over sine x. Secant x is 1 over cosine x, and hence you can say cosine x is equal to 1 over secant x. Tangent x is equal to 1 over cotangent x, so I can say cotangent x is equal to 1 over tangent x. Those are the 6 reciprocal identities. Then we'll talk about the ratio identities. And there are 2 of them, tangent and cotangent. So tangent of x is sine x over cosine x. Cotangent x is cosine x over sine x. The most important identities are called the Pythagorean identities, and I know that there are 9 of them. In fact, there are 3 of them, but we can go ahead and make them look like other identities and count it as 9 of them. So it starts with sine square and cosine square. So sine square theta plus cosine square theta is equal to 1. Then I can rewrite that as 1 minus sine square theta equal to cosine square theta, or 1 minus cosine square theta equal to sine square theta. Then the next one is tangent and secant. So tangent square theta plus 1 equal to secant square theta, or you can say secant square theta minus 1 equal to tangent square theta, or if I want, I can say secant square theta minus tangent square theta is equal to 1. And there is a similar one with cotangent and cosecant. So cotangent square theta plus 1 is equal to cosecant square theta. Cosecant square theta minus 1 is cotangent square theta. And cosecant square theta minus cotangent square theta is equal to 1. The new set of identities that I will write now are called the odd-even identities. These are sometimes very helpful and useful. The sine and the tangent function are odd functions, and hence the cosecant and cotangent are odd functions, whereas secant and cosine are even functions. So what I get to say? I get to say sine of negative x is equal to minus sine x. Cosecant of negative x equal to minus cosecant of x. Tangent of negative x equal to negative tangent x. Cotangent of negative x is equal to negative cotangent x. And all 4 of them are called odd identities. The even identities are cosine and secant. So cosine of negative x is cosine x. Secant of negative x is equal to secant x. And these are called the even identities. As usual, let's go to our lecture note and try to understand the problem. So in this section, what we will do, we will have to establish identities between the left-hand side of an equation and the right-hand side of an equation. So time to time, we will start with the left-hand side and arrive at the right-hand side, or we will start with the right-hand side and arrive at the left-hand side. So let's try to understand what is the objective with these problems. So the beginning of this section has just talked about the identities that we have already talked about. So we're going to start with problems. It says verify each identity. So as I said, start with the left-hand side. The left-hand side is cotangent of negative x times sine of negative x. Remember, both of them are odd functions, so you can write it as minus of cotangent of x multiplied by minus of sine of x. So minus times minus is plus. Cotangent is also by ratio identity cosine x over sine x. And if I multiply sine x with it, then I get to cancel the 2 sine x's, And my final answer is going to be cosine x. And remember, this is the right-hand side I wanted to arrive, and we have arrived. That is called a verification of the identity. And this is the only way we will work these problems out. Okay, so let's talk about the next one. If I start with the left-hand side, it is cosecant x minus secant x over cosecant x plus secant x. Now remember, cosecant is 1 over sine. So I'm using the reciprocal identity. And secant is 1 over cosine. The same thing on the bottom, 1 over sine x plus 1 over cosine x. Now, in order to add or subtract, I need the common denominator. So I'm going to multiply both top and bottom of 1 over sine x by cosine x, both on top and bottom. And the other fraction, 1 over cosine x, you multiply by sine x on top and bottom, on both top and bottom. So what do you have now? You have cosine x minus sine x over, remember the common denominator now has become cosine x sine x. And on the bottom you have cosine x plus sine x over cosine x sine x. Remember, dividing by a fraction means multiplying by its reciprocal, so I get cosine x minus sine x over cosine x times sine x times sine x cosine x over cosine x plus sine x. Clearly, I can cancel this with that. So I get cosine x minus sine x over cosine x plus sine x. I look at the right-hand side, I have to arrive at cotangent, and I know that cosine over sine is cotangent. So I divide this by cosine and sine, because again, remember, I have to go to cotangent. So divide this one by sine, but because I'm dividing the top by sine, I have to divide the bottom by sine as well. Let's see what we get. Cosine x over sine x is cotangent x, minus sine x over sine x is 1. Cosine x over sine x is cotangent x, plus sine x over sine x is 1. And that's exactly the right-hand side I wanted to have. So we have established the trigonometric identity. So this is the work that we are going to repeat. So in the next problem, we are starting with the left-hand side, and the left-hand side is in terms of tangent. So it is tangent x plus tangent y over tangent x tangent y minus 1. Use the ratio identity for tangents. So sine x over cosine x minus sine y over cosine y over sine x over cosine x. Tangent y is sine y over cosine y minus 1 is 1 over 1. Again, find the common denominator. So the first one, you have to multiply the denominator cosine y. So you're going to multiply cosine y on top and on bottom. The next one, you're going to multiply cosine x on top and on bottom. Whereas in the denominator, the common denominator is cosine x, cosine y. So I multiply all of that on top and bottom of 1. So cosine x, cosine y, cosine x, cosine y. Let's see what we get. We get sine x cosine y minus sine y cosine x all over the common denominator cosine x cosine y. On the bottom, I get sine x sine y minus cosine x cosine y over the same denominator cosine x cosine y. Dividing by a fraction is multiplying by its reciprocal, so write it as sine x cosine y minus sine y cosine x over cosine x cosine y times cosine x cosine y over sine x sine y minus cosine x cosine y. I can cancel the cosine x cosine y with each other, so what I'm left with is sine x cosine y plus, so this one, so on the top this was a plus, so it was my mistake, so just keep the sign on the top as a plus. So plus, then see you have sine y cosine x, but I can write it as cosine x sine y, over the bottom is sine x sine y minus cosine x cosine y. And see, that is exactly the right hand side I wanted to arrive at. So establishes my trigonometric identity. And the next problem is the first instance where we're going to use the Pythagorean identity. So this one is tangent to the power 4 minus secant to the power 4. So think about that as tangent square t all to the power 2 minus secant square t all to the power 2. So this is just the left hand side. Remember, I start with the left hand side. So that means I have the formula a square minus b square. So I should get a plus b times a minus b. So what I get? I get tangent square t plus secant square t times tangent square t minus secant square t. So if I am a little careful at this point, I will write this new expression as tangent square t. Remember, secant square is tangent square t plus 1. And the next expression, I write it by factoring out a minus. So what do I mean? You take out this minus sign and write secant square as positive minus tangent square as positive. Why did I do it? Because I know secant square t minus tangent square t is 1. So I get 2 tangent square t plus 1 times negative 1. So if you multiply the negative, you get minus 2 tangent square t minus 1. And look at the right hand side, it is exactly what you wanted. So you're done with this identity. The next identity is asking us to understand the proof from left hand side to the right hand side. So let's see whether we can understand it. I will just do it separately. So the left hand side is tangent of negative x times cosine x. Remember, tangent is odd, so you can write it as minus tangent x times cosine x, which is equal to minus sine x over cosine x is the ratio identity for tangent. And then finally, I cancel the 2 cosine x's and I get minus sine x's. So the steps tells me that the first one is the only correct one, because this one is wrong, as it said tangent is cosine over sine. This is similar, cosine over sine. This one has sine over cosine, but then there is an extra minus with the cosine. So that's not right. So hence I get to say that none of them are good. In fact, let me use a different color so that we don't confuse ourselves. So this is the correct one, and these are not the right ones. Alrighty, number 6. So left hand side, start with that. You have 6 cosine theta minus sine theta all to the power 2 plus cosine theta plus 6 sine theta all to the power 2, which is 36 cosine square theta minus 12 cosine theta sine theta, and this is just foiling 6 cosine theta minus sine theta twice, plus sine square theta. That's the first term. The second one is going to be cosine square theta plus 12 cosine theta sine theta plus 36 sine square theta. So first you observe that I can cancel this negative cosine theta sine theta and the positive cosine theta sine theta. So what I have left, I can write it as 36 plus 1, so 37 cosine square theta, 1 plus 36, so plus 37 sine square theta. So clearly I can factor out the 37 and get cosine square theta plus sine square theta inside. And by Pythagorean identity, that is 1, so 37 times 1 is 37. Okay. Number 7, it just asks you to find the value of the identity. So start with cosine squared x minus sine squared x over 1 minus tangent squared x. Now remember, the cosine squared x and minus sine squared x, I can keep it that way. I can say that this is cosine squared x minus sine squared x, whereas the tangent squared, I can change it to sine squared over cosine squared. So 1 minus sine squared x over cosine squared x. Find the common denominator by multiplying cosine squared x on top and bottom of 1, which is 1 over 1 by the way. So I get what? I get cosine squared x minus sine squared x all over cosine squared x minus sine squared x over cosine squared x. Dividing by a fraction means multiplying by its reciprocal, so cosine squared x minus sine squared x is getting multiplied by cosine squared x over cosine squared x minus sine squared x. And then I cancel these two terms. So my final answer should be cosine squared x. So that's option C. Similar problem in number 8. I want to find out sine to the power 4 minus cosine to the power 4. So we have done a similar problem. So first you have to write it as sine squared x squared minus cosine squared x squared. Then remind yourself the factoring of a squared minus b squared being a plus b times a minus b. So I get to say this is sine squared x minus cosine squared x times sine squared x plus cosine squared x. The second part is 1, so I get sine squared x minus cosine squared x times 1. Because I can write sine squared x as 1 minus cosine squared x by Pythagorean identity. So this is what I'm going to get. And times 1 doesn't change anything, so I'm not writing it anymore. So I get 1 minus 2 cosine squared x. So that's the first one. Then the problem number 9 is telling us to rewrite the expression in terms of the given function. So I want to write the expression tangent x plus cotangent x over secant x using cosecant x only. So let's see what we can do. Remember, tangent x is sine x over cosine x. That's a ratio identity. Cotangent x is cosine x over sine x. Secant x is 1 over cosine x. Common denominator on the top, so you multiply sine on top and bottom for the first fraction, and for the second fraction you multiply cosine on top and bottom. So you get sine squared x plus cosine squared x over cosine x sine x, the common denominator, all over 1 over cosine x. Now remember, sine squared x plus cosine squared x is 1. So 1 over cosine x sine x all over 1 over cosine x. That should be equal to 1 over cosine x sine x times the reciprocal of 1 over cosine x, which is cosine x over 1. So I get to cancel the cosine x term, and I get 1 over sine x. What is 1 over sine x? Reciprocal identity says that's cosecant x. And we're done with our problem. Problem number 10 is similar, asking you to rewrite the given term using tangent x. So let's start. I have tangent x over minus 1 plus secant x minus secant x over tangent x. So I get to multiply tangent x on the top and bottom of the first term, because I'm trying to find out the common denominator. So let's just do that. Whereas on the second term, you're going to multiply the other denominator. So minus 1 plus secant x, the entire term, you will multiply on the top and bottom. And let's see what we get out of this thing. So we get minus tangent square x. Actually, this is plus tangent square x. I don't know. And then I get minus. So minus times minus here is a plus. So plus secant x. Then this one is going to be minus secant squared x. All over, the bottom is the common denominator tangent x times secant x minus 1. So let's see what we get. So this is equal to secant x, then you say minus secant squared x minus tangent squared x. So what I have done, from this secant squared term and from this tangent squared term, I have factored out the minus over tangent x times secant x minus 1. So I get secant x, and remember the Pythagorean identity secant square minus tangent square is 1, so it is secant x minus 1 over tangent x times secant x minus 1. So we're pretty much there, because now we will cancel secant x minus 1, secant x minus 1. So my final answer is going to be 1 over tangent x. And I wanted the answer to be in terms of tangent x, and we obtained the answer. Rewrite the following expression in terms of the given function or functions. So I'm going to write it in terms of sine. So that should be pretty simple, because I'm starting with sine squared x plus sine x minus 1 plus cosine squared x. Think about the Pythagorean identity. Sine squared plus cosine squared is 1 plus sine x minus 1. So 1 and 1 will cancel each other, and I will just get sine x. So that is going to be my answer. Rewrite the following expression again. This time you're going to write in terms of cosine and sine. So I have cosecant x plus tangent square x times cosecant x. So let's see what we can do with it. I will change everything in terms of sine and cosine. So reciprocal identity will give you 1 over sine x. Tangent square is sine square x over cosine square x. And then cosecant is 1 over sine x. So you get 1 over sine x plus, so one of the sine square is going to cancel, and I will get sine x over cosine square x. Now it is time to find the common denominator. So I multiply the first fraction by cosine square x on top and bottom. And the second function should be multiplied by sine x on top and bottom. What I get? Cosine squared x plus sine squared x all over sine x. Cosine squared x is the common denominator. But Pythagorean identity says that cosine squared plus sine squared is 1, so it is 1 over sine x times cosine squared x. And that should be my answer. So it's in number C. Now this time I didn't give you the answer in which words you have to write it, in which terms you have to write it. You just have to simplify this. So let's try to work it on. So I'm starting with sine x plus cosine x whole to the power 2 all over 1 plus 2 sine x cosine x. So when I FOIL the top, I get sine squared x plus 2 sine x cosine x plus cosine squared x all over 1 plus 2 sine x cosine x. Remember, sine squared x plus cosine squared x is 1, so I get 1 plus 2 sine x cosine x over 1 plus 2 sine x cosine x. So the entire term from top and bottom will cancel, and I will get 1 over 1, which is 1 as my final answer. So B is the correct choice. Number 15. Simplify and write the trigonometric expression in terms of a sine and cosine. So I can only have sine and cosine in it. So we're going to say cotangent of negative x. Remember, odd function means it is minus cotangent of x. Cosine of negative x is even, so it is cosine of x. And then finally we have sine of negative x. It's odd, so we get minus sine of x, which is equal to minus cosine of x over sine of x times cosine of x minus sine of x over 1. So if I want to find the common denominator, I have to multiply sine of x on top and bottom. And I will get minus cosine squared x minus sine squared x over the common denominator of sine x. which is minus cosine squared x plus sine squared x over sine x, and that is minus 1 over sine x, which is equal to minus 1 over fx. So if someone asks you, what is the function fx? Your answer is going to be fx is sine x. Just comparing, you would say fx is equal to sine x. And again, simplify and write the trigonometric expression in terms of sine and cosine. And I have to have my answer in the form fx squared. So the question will be, what is fx? So I'll start working. So I have 2 plus tangent squared x over secant squared x minus 1. And see what I do with this. The first thing I will do, I will write it as 1 plus tangent squared x. That's 2 over secant squared x minus 1, which is equal to 1 over secant squared x, and then 1 plus tangent squared x is secant squared x itself, and then you have this minus 1. So now distribute, write it as 1 over secant squared x plus secant squared x over secant squared x minus 1. 1 over secant squared is cosine squared x plus 1 minus 1. So this is cosine squared x. But remember, this is cosine x whole to the power 2, and that should be your f of x whole to the power 2. So fx is going to be the inside, which is cosine x. And that should be the answer to the question. Number 17. Simplify and write the trigonometric expression in terms of sine and cosine. So I have cosine on top, the bottom is secant. That's what I need to work with. So I will say this is 1 plus cosine y over 1 plus 1 over cosine y. Common denominator again, so write it as 1 plus cosine y over cosine y plus 1 over cosine y. Then dividing by a fraction, so 1 plus cosine y times cosine y over 1 plus cosine y, the reciprocal of the bottom fraction, cancel the similar terms, and your answer is cosine y. And you're done. Secant t minus 1 over secant t plus 1 equal to a minus cosine t over a plus cosine t. Then what is a? So all I need to do is think of secant t as 1 over cosine t minus 1 over 1 over cosine t plus 1. Again, common denominator, so I will get 1 minus cosine t over cosine t over 1 plus cosine t over cosine t. Dividing by a fraction means multiplying by the reciprocal. So it's cosine t over 1 plus cosine t. So we're almost there. So my answer is 1 minus cosine t over 1 plus cosine t. But I wanted it to look like a minus cosine t over a plus cosine t. So a must be 1. So the next one, I'm going to prove the identity. So remember, I'm starting with 1 plus tangent a plus secant a times 1 plus cotangent a minus cosecant a. So the first line is given for us. What we're doing, we're writing by distribution. So 1 times 1 is 1. 1 times cotangent is cotangent. 1 times negative cosecant is negative cosecant. Then you distribute the tangent, so you get tangent. Tangent times cotangent. Tangent times cosecant. Finally, I have to distribute the secant, so I will get secant. Secant times cotangent and secant times cosecant. That's just distribution. Now what I'm doing, I am writing it in terms of starting with tangent A. So I have taken care of this term. That's tangent A, so that's there. Then it says it should be plus something minus secant A times something plus 2. So that's where we're going to start working on. So think about tangent A times cotangent A. How much is that? That is 1. Also, if you think about secant A times cosecant A. Secant A times cosecant A, they are reciprocals of each other, so that must be equal to, actually they are not reciprocal of each other, I'm so sorry, that's cotangent. So let's see. One thing we can do, we can just rewrite this one more time. So let's say 1 plus cotangent A, that's the second line, minus cosecant A plus tangent A, and then see what we get. So I already said tangent A times cotangent A is 1. If you do tangent A and cosecant A, tangent A is sine A over cosine A, and cosecant A is 1 over sine A. So they cancel, you get 1 over cosine A, which is secant A. So what I can do instead, I can write this is minus secant A. That's easier, I think. Then you have plus secant A. So that's very nice because they will cancel each other. Then I have secant A cotangent A. So what is that? Again, secant is 1 over cosine. And cotangent is cosine A over sine A. So cosine cancels. You get 1 over sine A, which is cosecant A. So I can go ahead and say that this is plus cosecant A. And then as I said, minus secant A cosecant A. So that should be minus 1 over cosine A times cosecant A is 1 over sine A. So this is minus 1 over sine A cosine A. So minus 1 over sine A cosine A. Okay, so now we are going to try to make sense of the third line. So first and foremost, I have the tangent A, which is here. So I've taken care of this term. What else I have? 1 plus 1 should be 2. So I've taken care of this term. And now see, you have negative secant, positive secant. You have negative cosecant, positive cosecant. So they're gone. What else you have? You have cotangent A. So that must be cotangent A. And you have one other term, and that's this term. But if you remember, this term was actually the term secant A cosecant A. So I didn't yet simplify it, but it's good because in future we will simplify that term. So the third line, tangent, write it as sine A over cosine A. Cotangent is cosine A over sine A. Minus, now you are going to say secant cosecant is 1 over sine A times cosine A plus 2. So now you found the common denominator, so you multiplied this one by cosine on top and bottom. In fact, you multiplied this one by sine on top and bottom, and this one by cosine on top and bottom, so that I get the common denominator of sine A cosine A. So what I get? I get sine square A, see this is sine squared A, plus cosine square A, and I know that that is going to be 1. So it is 1 over sine A times cosine A, minus, I get the other term that I had is also a 1, it's here, over sine A cosine A. So what we get 1 minus 1 over sine A times cosine A, and that is a 0, so this first term is 0, so the only term remaining is 2. And that's how we will prove that the given expression is equal to 2. There are a couple more problems. So the next one is negative tangent squared x minus 1 is over secant squared x. So just factor out the minus, so you get tangent squared x plus 1 over secant squared x. So this is minus secant squared x over secant squared x, and that's negative 1. Now I have sine to the power 3 of negative x equal to sine to the power 3 of x minus sine x. Let's see what we get. First and foremost, think of this as sine of negative x whole to the power 3. And then factor out sine x from the bottom, so you get sine squared x minus 1. Now, the top will be minus sine x whole to the power 3 over sine x times sine square x minus 1. So I get minus sine to the power 3x over, if I factor out a minus from the bottom as well to cancel the minus on the top, I get sine x times 1 minus sine squared x. That's nice because 1 minus sine squared x is cosine squared x. So this is equal to, and also I can cancel 1 sine x from top and bottom, and the minuses are going away. So I get sine squared x on the top, and the bottom, remember the sine x is gone, 1 minus sine squared is cosine squared x, and that's tangent squared x. So your answer is tangent squared x. 1 minus 1 over cosine squared x. So write 1 as cosine squared x over cosine squared x minus 1 over cosine squared x. So that's cosine squared x minus 1 over cosine squared x, which I can write as minus of 1 minus cosine squared x. And I did it because I know 1 minus cosine squared is Pythagorean identity, and that's sine squared x. So this is minus of sine squared x over cosine squared x, and that's minus of tangent squared x, and that's my answer. So you have to write tangent x plus secant x whole to the power 2 in terms of a plus sine x over b minus sine x. So we'll start with tangent x plus secant x whole to the power 2. So what I can do, I can write it as sine x over cosine x because my answer is in terms of sine x. And then secant x, write it as 1 over cosine x whole to the power 2. So that is sine x plus 1 over cosine x. Cosine x whole to the power 2. So if I square, I get sine x plus 1 whole to the power 2 over cosine squared x. That's just taking the square on the top and bottom. So on the top you get sine x plus 1 times sine x plus 1. That's the square. On the bottom, cosine squared is 1 minus sine squared x. Again, remind yourself, a square minus b square is a plus b times a minus b. That's the factor. So I get to say this is sine x plus 1 times sine x plus 1 over 1 is 1 square. So it's 1 plus sine x times 1 minus sine x. So I'll cancel them, and I will get 1 plus sine x on the top, 1 minus sine x on the bottom. And my answer, remember, should be of the form a plus sine x, which I have a plus sine x over b minus sine x, which I have 1 minus sine x. So a is 1 and b is 1 as well. And that is pretty much all we wanted to do in this section of trigonometric identity. Now this is a section which is very abstract and intricate. So you need to work on your homeworks, and if you have problems, then come to class and ask me questions, because that is one thing that is not going to be coming to you very naturally, normally. So keep working and let me know if you have any questions.